Okay, we're talking about review worksheet 3. The biggest thing you guys need to know is it's very similar to the test, but you guys have got to think. This first page is 17 through 24 from the section 4. From section 4.3, I believe. Yes, it's on page 274, section 4.3. That whenever I first taught it, I said this is part A text, and you guys looked at me like I had 10 heads. Same exact thing. It's still there. If you recall, I told you guys on your lock screen of your phones to put quadrant 1. Didn't I? You have got to have it memorized. If you don't, this is why you sucked on part A test. Okay, I love you dearly. I want you guys to be able to do well in this, but you cannot be successful in this if you do not understand quadrant 1. So, review of quadrant 1. Okay? Hands of the clock, 0, 1, 2, 3. Where are those coming from? They're the numerators of the ordered pairs of the x-axis, right? So this is 1/2 square root of 3 over 2. This is square root of 2 over 2, square root of 2 over 2. This is the square root of 3 over 2, 1/2. And they correspond, this is 0, 1. They correspond to values 90 degrees, pi over 2. 60 degrees, pi over 3. 45 degrees, pi over 4. 30 degrees, pi over 6. 0 degrees, 0 radians, which is the point 1, 0. You have to memorize that. Because if I come back over here to this page and it says, hey, all it's asking for in quadrant in the first column is the degree measurement. What it's asking for in the second column is the equivalent of the degree in radian measurement. And then in the last function value column, it's saying, okay, well, look at the very first column and say, well, I want the cosine of that. So think, I'm not even going to go, I'm literally going to go through this test and be like, okay, 30 degrees is pi over 6, pi over 4 is 45. Don't know that one yet. 45 is pi over 4. Oh, don't know that one yet. Don't know that one yet. Oh, here's pi over 6, that's 30 degrees. Here's 0, that's 0 radians. Yeah? Yeah? How many of you did not do that on the test? Did you see how easy it was whenever you looked at it from that standpoint? Were you making a mountain out of a molehill? Uh-huh. Right? Okay, so now if I go back to finish those and be like, okay, 30 degrees. 30 degrees corresponds to the ordered pair, hands of the clock, 1, 2, 3, square root of 3 over 2, comma 1/2. I want the cosine. Cosine is x, so it's the square root of 3 over 2. Yes? Oh, well, this is 45 degrees. 45 degrees corresponds to the ordered pair square root of 2 over 2, square root of 2 over 2. Okay, well, I want the cosecant. What's cosecant? The reciprocal of sine. So I want the reciprocal of sine, so that's 2 over the square root of 2. Do I like that? No, I won't accept that. Rationalize that. So that's 2 square roots of 2 over 2, which is just the square root of 2. Yes? Super easy. Something you did not do. Okay? Now, look at this. This is a problem. Cotangent. Okay, well, let's be really honest about this. If I go back to this over here, when my cosine and my sine are the same, x and y, and I take my x value divided by my y value, or my y divided by my x, they're the same. What should that be? Square root of 2 divided by 2. Square root of 2 over 2 divided by square root of 2 over 2. What is it? Yeah. The tangent of this is going to be 1. Well, it's a dead giveaway. You know it can't be 45, right? So it has to be one of these angles. It has to be either 60 degrees or it has to be 30 degrees. How do I know? Well, it's a very easy concept. You simply calculate. So if I do the tangent, and actually I want to do the cotangent of 30 degrees, that's x x over y, so that's the square root of 3 over 2 divided by 1/2. The 2's cancel out, that's the square root of 3. Is that it? So it has to be the other one, doesn't it? So it has to be 60 degrees, which means 60 degrees goes here, which means what's the radian equivalent? Pi over 3. Do we understand how to attack that page now? Am I done? Do we get it? Okay, it's not nearly as hard as what you guys made it. What's the key to that page? You don't know this, you're done. You're done. Yes? Okay, next page. Determine the quadrant that each angle lies. As soon as you get there, I want you to say, okay, what's my denominator? 5, right? So where's my pizza pie? Here's 5 pi over 5. That means I have how many slices up top? How many slices in the bottom? 5. And how many slices do I want? I only want one slice, which means my one slice is over here, so that's in what quadrant? Quad 1. Right? Go to the next problem. My denominator's a 9. So what am I going to split this up into? I have 9 pi over 9. However, it is negative. So what's the negative mean? I'm opening clockwise down and to the left. Down and to the left is the direction I'm opening. I have 9 slices in the bottom, and I have 9 slices in the top, right? How many slices do I need? I need 11 slices, which means I need to take all 9 at the bottom and then 2 more up here. Yes? So what quadrant am I in? I'm done. Do we understand that? Yes? Okay. 1/3 revolution counterclockwise. Let's counterclockwise. Down and to the left or up and to the right? I should say down and to the right or up and to the left. I said that backwards. Yeah, but I was trying to go this way. I get what you're saying. It's hard to describe it either way. So if I want 1/3 of a revolution, I literally want you to take your pie, your circle. Do you see your circle? And divide it into thirds. But which way are you going? You're going this direction. Okay? So here is where you're starting. I want 1/3 of my circle. So therefore, there's 1/3 of a revolution. Do we see it? Yes? Yep, I'm not going to do them all. You guys are nuts. Okay, problems 6 through 9. I cannot tell you. This is the most basic thing that there is. Express each as a degree, measure as a radian. Using pi. Okay, so what does that mean? How do I go from degree to a radian? Multiply by a value of 1. 1 is equivalent to pi over 180 or 180 over pi. What am I trying to cancel out? Oh, shoot, is right. You're multiplying by pi over 180 here. So this is going to be pi over 180. The degrees cancel out. The zeros cancel out. You have 15 pi over 180 or 18, which reduces down to be 5 pi over 6. And let's be honest. You memorized the unit circle. Is 150 on the unit circle? Yes, it's 30 degrees away from 180. Pi is 180. A denominator, a 30-degree angle has a denominator of 6, so it has to be 5 pi over 6. Okay? You guys should be able to do those without any problems. Okay, down here, 10 at 3 over 13. How do I do that? I do the opposite. I'm going to multiply by 180 over pi. Because I want the pi's to cancel out. Pi's cancel out. You have negative 7 over 180 over 4. When you type that in your calculator, you're going to get negative 315 degrees. Literally, type it in and let the calculator do the work for you, right? Any questions? Okay, 14 through 16. This was super easy, but you guys screwed it up majorly. What's complement? Do you know what you guys did on this? You guys thought coterminal. And it's not. Complement's 90, supplement is 180. You literally swapped it in your brain with the coterminal concept, and that's not what it is. Okay? So immediately, if I want the complement, I'm going to take pi over 2 and subtract off 2 pi over 5. Yes? Yes or no? Get a common denominator. Common denominator is going to be 10. So what did I multiply 2 by to get 10? 5. What did I multiply 5 by to get 10? 2. So 5 pi minus 4 pi is 1 pi over 10, not 110. Yeah? Okay. Well, let's make this really, really easy in your brain. Supplement. That is going to be denominator of 5, which means this is 5 pi over 5. Yes? How many slices of the pie did I want? 2 slices, so how many remain? Isn't that easy? So this is going to be 5 pi over 5 minus 2 pi over 5 to give you 3 pi over 5. It's super duper easy. How many of you want to hit yourself in the head right now? I'm not doing any more. Next. Find the length of the arc on the circle with the given radius. And I think on the test, I took off this right here. So I will take that off. Because on the test, I told you to use 22. I didn't tell you to use 22 over 7. Okay? So if I want this right here, what is my fatal mistake here? Fatal. Like you're dead in the water, guys. There's no potential way you can do the problem if you make this mistake. The formula you have to use is S is equal to R times theta. Has to be in radians. It has to. If you don't put 330 degrees in radian mode, you will screw up the entire problem. So what is 330 degrees equivalent to? 11 pi over 6. So this is 2.8 times 11 pi over 6. And if you type that in the calculator, I mean, legitimately, type it in exactly the way you see it, using the pi, you should get, let's see here, 2.8 times 11 divided by 6 times pi. You're going to get 16.13. Do we understand that? And what I did in the calculator is I took 2.8 and hit enter. Then I went ahead and took that times 11 divided by 6 and hit enter. Then I took that times pi and hit enter. Because if not, it does it all jacked up in the calculator. So you have to be super duper careful. Okay? So just to show you what I did. 2.8, hit enter, times 11 divided by 6, hit enter, times pi, and hit enter. 2.8 times 11 divided by 6 pi. I don't know that it'll give you the same answer. It will, so just be careful. So it will work. Okay? All right. Now, that brings us to the next concept down here. Determine a positive and negative coterminal angle with the following angles. How do I do that? Coterminal means we're trying to find another angle that is a whole revolution away. A whole revolution is either 2 pi or 360. And this one is going to be 2 pi. So you're going to add 2 pi or subtract 2 pi. Do we get that, yes or no? So if I do that here, I'm going to subtract 5 times 2 is 10 pi over 5. Yes? So that's going to give you negative 17 pi over 5. Yes? Yes? Change this to plus, and that's going to give you 3 pi over 5. Anybody a little bit irritated right now? Okay, do we understand that? Okay, find the point x, y on the unit circle. What's x and y? Cosine and sine. That's that ordered pair of your quadrant one that it wants you to look at. Okay? And it says that corresponds to the real number t, and evaluate, if possible, the sine, cosine, and tangent of each function. Now, I didn't change the directions there. I gave you all 6 trig functions. I wanted you to find them all 6. All right? So, with that being said, I need to know, where is 5 pi over 6 at? Denominator is 6, so this is going to be 6 pi over 6. So, where's it at? It is in quad 2, and what do we know about being in quad 2? That's the very first thing I need you to think about. And then afterwards, I want you to be like, oh, I have a denominator of 6. What's the ordered pair that corresponds to a denominator of 6? Hands at the clock. 6 is down here at the bottom. 0, 1, 2, 3. That's the ordered pair of the square root of 3 over 2, comma 1/2. But I'm in quadrant 2, so in quadrant 2, the x value is negative. Why did I do that? Because now can I find all of those? Okay, so what's the sine of 5 pi over 6? 1/2. What's the cosine of 5 pi over 6? Negative square root of 3 over 2. What's the tangent going to be? The 2's cancel out. Negative 1 over the square root of 3, which is negative 3 square roots of 3 over 3. Yes? Negative square root of 3 over 3. Yes? If I know those 3, then what do I immediately have? This is going to be 2. This is going to be negative 2 over square roots of 3, which is negative 2 square roots of 3 over 3. And this is going to be negative square root of 3. Yes? I think I may have put an error on your worksheet. I didn't change one of the parentheses there, so be careful. I changed it on mine, but I did not change it on yours before I made the copies. Okay? It's actually problem 23 that I did that to. Okay, do we have any questions on that? Now, what threw you off is on the test, I didn't put quadrant or point there, did I? Because those were something you were mentally supposed to think about. That was your bunny trail. I didn't want to put a bunny trail for you. I needed you guys to find the trail yourselves. Crash and burn. You did not find the trail. You didn't know that you were a bunny. You know you were supposed to be looking for trails. It was a problem. Okay. Next page. Evaluate the 6 trigonometric functions using the period of the function. Time out. What does that mean? And I'm not doing 23 because I've done that 15,032 times. I'm doing 24. What does this mean if I'm saying using the period as its aid? Where is negative 13 pi over 6? What's the bunny trail tell you to do? The bunny trail tells you to find the coterminal on the unit circle. Coterminal. Oh, is this a corkscrew angle? Is this like not on my unit circle? Yep, it's not on my unit circle, so let's find the coterminal. So it's a negative 13 pi over 6. So instead of subtracting, what am I going to do? I'm going to add 12 pi over 6, which is 2 pi. So what's negative 13 pi over 6 and 12 pi over 6? Negative pi over 6. Hey, is that on my unit circle yet? It's negative. So it's not on my unit circle yet. So I need to do it again. which gives you 11 pi over 6. Is 11 pi over 6 on my unit circle? It sure is. So 11 pi over 6 is the angle that I'm thinking about. And that is in what quadrant? That is in quadrant 4. And in quadrant 4, what do we know about my cosine and sine values? In quad 4, positive, negative, right? Which means, what is the ordered pair that I should be thinking about? Well, ding, 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 and I already knew the angle because it has a denominator of 6. So hands of the clock, 0, 1, 2, 3. That is going to be the square root of 3 over 2, comma, a half. However, which one is negative? The y value, which is going to be the half, is negative. Can I find all 6 trig functions now? Door. Here, maybe I'll say this is the map y'all need to use. Backpack, backpack. Right? Do we understand this? So what is the sign at negative 13 pi over 6? It's right there. Tell me what the sign of negative 13 pi over 6 is. Negative 1/2. What's the cosine? What's the tangent? Negative 1 over the square root of 3, which is negative square root of 3 over 3. I'm done. You guys can find the rest. Do you understand that? How many of you feel like if you just would have thought a little bit more clearly, you probably would have been able to do this yourselves? Okay. Next. What do we have? It says evaluate the following for the using a calculator. Guys, you just have to make sure you're in the right mode. And what do I recommend doing? Always making sure that you are in radian mode. So touch your battery. Your battery says I'm in degree. I don't want to be in degree, so I'm going to go to document settings, go here and put it in radian. And I'm going to make that my default from now on. And I'm simply going to go back here and it says to do the cotangent of 3.7 r. What's that r mean? Radian. So trig. And I want the cotangent of 3.7. I'm already in radians, so just write it down. And that has to go to 4 decimal places, 1.6007. It's very simple. You know how many of you did not make sure you were in the correct mode? If I said to do degrees, if I'm in radian mode, it's okay. If I say I want the cosine of 45 degrees, come down here in the pi and get that degree key. And it's going to be that. How do I know that that's the square root of 2 over 2? Well, that's the square root of 2 divided by 2. Oh, I know I'm right. Yes? Do we see that? It's a check and balance system. Okay, next one. Find the exact values of the 6 trigonometric functions given the following triangle. Please simplify and rationalize the denominator. Yes, sweet bejeebus. That's exactly what it is. You are going to do a squared plus b squared equals c squared. So a squared plus b squared is equal to c squared. A is going to be, we don't know. B is 2 squared. C is 6 squared. So a squared is equal to 36 minus 4. So a squared is equal to 32. Yes? 32, if I take the square root of that, that's going to be the square root of 16 times 2. So that's going to be a is equal to 4 square roots of 2. Yes or no? Do we understand that? 4 square roots of 2. Yes? So if this is going to be 4 square roots of 2, can I find the 6 trig functions now using SOHCAHTOA? Can I? Absolutely. Sine is going to be opposite over hypotenuse, which is 1/3. If I know sine, then I know automatically what? Cosecant is the reciprocal, 3. Cosine is adjacent 4 square roots of 2 over the hypotenuse 6. Reduce 4 over 6. What's that going to be? 2 square roots of 2 or over 3. So if I know that, then I know that secant is 3 over 2 square roots of 2, which is going to be 3 square roots of 2 over 4. Because the square root of 2 times the square root of 2 is 2 times 2 is 4 then. And you guys can do the rest. Yes? Okay, next page. Now, I'm going to be real honest. This one is complete logic. You don't even have to use any trigonometry on problem 30. What's the sign of 30? Unit circle. 1, 2, 3. I want the sign. What's the sign of 30? Thank you. What's the cosine of 30? Square root of 3 over 2. Right? They give you a sine and cosine of 60. So what's the tangent going to be? Tangent's going to be the square root of 3 over 2 over 1/2, which gives you the square root of 3. Yes? So what's the cotangent going to be? The reciprocal of that, which is the square root of 3 over 3. Was that not ridiculously easy? Unit circle, baby. Unit circle, quad 1. Okay, this one right here. Same exact concept. If I know the cosecant is 3, then what else do I know? Sine is 1/3. If I know the secant is 3 square roots of 2 over 4, then what else do I know? What's the cosine? 4 over 3 square roots of 2, which is going to be 4 square roots of 2 over 6, which is going to be 2 square roots of 2 over 3. Yes? Can you find the rest of them then? Your formula sheet says that the secant of 90 minus theta, is equal to the cosecant of theta. So what's that going to be? 3. It's given, right? Okay, now I'm going to come over here to 32. If I know the tangent of theta is 5, what's the cotangent? 1/5. Letter C, the tangent of 90 minus theta is equal to the cotangent according to your formula sheet. So that's going to be equal to what? 1/5 again. I need to find cosine and cosecant. The only thing I know is that tangent is positive. Where is tangent positive? Tangent is positive in quadrant 1 and in quadrant 3. That's all I know. Correct? I don't know anything else. Which means sine and cosine can either be positive or sine and cosine can be negative. So for this one right here, I have to have plus minus. Do you agree? For this one down here, I have to have plus minus. I have to. So I'm going to simply use my trigonometry. 1 plus tan squared is equal to the secant squared. If I know secant, then what else do I know? Cosine. If I know secant, then I automatically know cosine, right? So this is 1 plus 5 squared is equal to secant squared. So this is 26 is equal to secant squared. So this means that secant is equal to the square root of 26 plus or minus. But I don't want secant. What do I want? I want the cosine, so therefore the cosine of theta is the reciprocal of that. So that's 1 over plus or minus the square root of 26, which is plus or minus the square root of 26 over 26. Do you understand that, yes or no? Yes? Same exact concept of cosecant, but what trigonometry would you use on that one? You're going to use that trig identity, right? Okay, use the trig identities. We've talked about this many times, I feel like. You have to know your formula sheet. I gave you the formula sheet as you took the test, did I not? You have to know what to use and when to use it. That takes training your brain, okay? What are the simplest trig functions that you know? Sine and cosine are your simplest trig functions. So if they're your simplest trig functions, your goal is to make your left-hand side look like your right-hand side of 33 and 34. Yes? I have tan and cotan multiplied together. There's multiple ways you could do this. You could put them on sine and cosines, or you can put them in terms of tangents or all cotangents, whatever your brain thinks of. If your brain thinks in terms of sine and cosine, well, this is the sine of theta over the cosine of theta times the cosine of theta over the sine of theta. What happens? Every single thing cancels out, and when things cancel out, what value are they? 1. So 1 is equal to 1, so I know I'm right. However, on 34, aren't those already in terms of sine and cosine? So I can't get it any simpler. So I needed to go back to what you know. What you know are fractions. 1/2 plus 1/3. What would you do? Get a common denominator. Apply that foundational knowledge to trig now. What's your LCD between cosine and sine? So I need this one to turn into cosine sine, and I need this one to turn into cosine sine. Yes? What did I multiply cosine by in the denominator to get the new denominator of cosine times sine? I multiplied it by sine. What you do to the bottom? You do the top. So I'm going to drop down the original numerator, and I'm going to tack on what I multiplied by. Yes? Go to the second fraction. What did I multiply the denominator of sine by to get the new denominator cosine sine? Cosine. What you do to the bottom? So I'm going to drop down the original and tack on another one. Thank you. They correct. Okay, thank you. Appreciate it. Okay, now write this as one fraction. So I have sine squared theta plus cosine squared theta. Yes? Any recognition? Recognize anything? Nope. Look at that formula sheet. What's that? Sine squared plus cosine squared. It is 1. So I have 1 over the cosine of theta times the sine of theta. Separate them in the way that you need them to be separated. And you can't really see it because it's so tiny, but it is what it is. So we needed it to equal cosecant and secant, and that's what it equals now. Do we see that? Yes? Okay, last page. Bell's gonna ring here. Last page. We did these. We did these in class. These were problems 53 through 56 on page 275. It says solve for x. I give you the inside angle of 60 degrees, and I want you to find the outside measurement leg. According to 60 degrees, what is 38 in the triangle for SOHCAHTOA? It's opposite. According to 60 degrees in the triangle, what is x according to SOHCAHTOA? Adjacent. What trig function deals with opposite and adjacent? So the tangent of 60 degrees, which is just a number, is equal to my opposite leg of 38 divided by my adjacent leg of x. How do I solve for x? Cross multiply maybe? X times the tangent of 60 is equal to 38. So x is equal to 38 divided by the tangent of 60. Go over to your calculator and type that in. Control division, 38 divided by the tangent of 60. Make sure that you have the degree symbol there because we're in radian mode, and hit enter. 21.94. Yes? Make sense? The same thing you do for 36. Now, for 37, a 30-meter line is used to tether a helium-filled balloon. It's in the wind, folks. The string on your balloon is how long? 30 meters. Because of a breeze, do you see it blowing in the wind? Here I am down here. I have the balloon hanging on. There's my balloon up in the air. Here's 30. How high up in the air is it? It needs this height, right? And it says because of the breeze, it creates a 75-degree angle. According to 75 degrees, what is x? Opposite. What is 30 according to the 75 degrees? Hypotenuse. So this is the sine of 75 is equal to opposite x over 30 hypotenuse. How do I solve for that? Absolutely. So you have 30 times the sine of 75 is equal to x. So if you come over here and you type that in, 30 times the sine of 75 degrees, and hit enter. So the height of the balloon is 28.98 meters. Do we see that? Yes? Okay. That's the worksheet that you're doing over your snow days. Okay? Okay, guys, make sure you get it done.